Hey everyone, welcome to InsightsByRish. This is the fourth tutorial for machine learning using PySpark series. In this tutorial, we will be understanding about how to perform data cleaning using PySpark. In the previous three tutorials, we have seen some basics about PySpark, like how we can start the Spark session, how we can add, delete and rename the columns, and then how we can create the manual data frames. So in this session, we will be focusing about handling the null values and performing imputation. So I will be using this demo dataset created by me just for the simplicity purpose. I will provide this dataset in the description box. Let me come back to the Jupyter notebook, and here we will first start the Spark session. So let me just write here, starting this Spark session. This basic stuff has already been covered in the previous three tutorials, so I will also link them in the description box. After that, we first have to load the Spark session here. So from PySpark.sql, we have to import the Spark session. After importing that, then we have to start the Spark session. So here I will create a variable named as Spark, and in this I will load the Spark session. Builder.appName, and here you have to give some name to your session. So let's name this session as tutorial 4, and then get or create. So if the session already exists, then it will be extracted, and if it doesn't exist in past, then it will be created. Let's run that. Now let's see what's stored in this Spark variable. So as you can see, here we have the version of PySpark that we are using, the cluster that we are working in, which is the local, and here we just have a single cluster, and then the name of session. Now after that, let's load the dataset here. So loading the dataset. To load the dataset, here I will say df, then Spark, then read.csv, as we are reading the CSV file. Then you have to provide the path of CSV file. So let me just say demo data.csv. Then few mandatory attributes, which are header is equal to true and info schema is equal to true. The significance of these attributes, I have already explained about this in the previous tutorial, so refer that. Let's run this. Let's visualize our dataset here using the show method. So as you can see, we have few null values in every column that we have. Now first we will check for null values, because this is a very small data set and hence we can manually count the number of null values from this. But in case when we have large data sets, we cannot count the number of null values from every column. There we have to write a function. So let's just do that. Let me write here, checking for null values. So in pandas, it is very simple to check for null values, where you just say df.isNA.sum, but here it's a bit complex. So let me just import some modules here. So from PySpark.sql.functions, we have to import column, when and count. Let's run that. Now here we will say df.select. So here we want to display the count when the column C is null, comma C, and here we will say alias, because this C is an alias to the columns from data frame. So for C in df.columns, just a minute, fine, and then we will say here show. Let's run that. So on your screen, you will get displayed with the count of null values from each column. So here we have 2 null values in the H column and 1 in remaining 3 columns each. So this is how you can check for the count of null values from every available column of your dataset. Now after checking for the null values, now we have to handle them, but we have to handle for different data types separately. For example, let me just show you the schema here. So here I will say df.print schema. So here you can see that your degree is a string column which consists of string values basically, and the remaining 3 columns are your integer columns. So you have to handle the null values for both these columns separately. Like for string column you have to use a different method, and for the remaining integer columns you have to use a different method. So let me just start here with method 1, and this method 1 is dropping the null values. This is a very basic method, and by dropping the null values, what I mean is we don't drop the null values from any specific column or the column with any specific data type. When you drop the null values, it gets dropped from all the available columns that you have in your data set, irrespective of their data type. So let me just do that, and I won't be making any changes in the original data frame because I have to show you various methods. So for every method I again have to load the data set, and hence I will just create a copy of that. So I will say here df1 is equal to df. Let's run that. Now df1 holds the df data set, but whatever changes we will make in df1 won't make any changes in the original data frame df. So here we will say df1 is equal to df1.na.drop. Let's run that, and let's again run this cell to check now the count of null values after dropping the null values. So here I will just make a df1 everywhere. Let's run that, and as you can see, now we don't have any null values in any of the columns. Now this code snippet like df1.na.drop, you can also write it in a different way, and what's the different way is, let me just create one more copy of the data frame here, and here we will say df2 is equal to df2.dropNA. So instead of na.drop, you can also use the dropNA method here. Let's run that, and let's again check the count of null values. So let me just make it 2. Let's run that, and both the methods does the same work of dropping the null values, but just the way of writing is different. You can use either of them. You can either use this one or you can go for this one as well, whatever you like. So these are the ways, like this was the first method of dropping the null values. Now the second method that we have is dropping the null values from specific column. Let me just show it to you. So method 2, and this is dropping the null values from specific columns. Being said that, here I will again create a new copy of data frame. So df3 is equal to df. Now here we will be dropping the null values from specific column. Like we have null values in all of the columns that we have here, like from degree up till salary. But let's say that we have to drop the null values just from the degree column. Basically what it will do is, let's say I have given the subset as degree. Then it will only drop the rows where the null value is present in the degree column. Like for this particular row where the null value is specifically present in the degree column, only this particular row will get dropped, because for the remaining null values we have some value present in the degree column, and hence that rows won't get dropped. So coming back to this cell, let me write the code here. Here I will say df3 is equal to df3.na.drop. Again you can use the dropNA method as well. Then here we have to give the subset for which we want to check the null values. As I said initially, we will do it for degree column, and let's run that. Now let's again call this code here to check the count of null values. Just a minute, let me make it 3. So as you can see, we don't have null values, or null values are removed just from the degree column. This is because what this code did is basically it checked for row which consists of null value in the degree column, and it only removed that specific row, not all the null values. So this is how it can work. If you give a different subset here, let's say that you give a different subset called age. Let us even do that. I will create one more copy of data frame here, and here I will say df4.na. I will show a different method here of dropNA, and again you have to give a subset here. So let's say this time we are giving the subset as age because it consists of 2 places where it holds the null values. Let's run that, and let's again call this code to check the count of null values. I will make it 4. Let's run that, and as you can see, you are just having 0 on the place of age, eventually salary. Let's see what happened. So if you check your data frame here, you can see that you are having 2 places where the age column holds the null value. first row is this and the second row is this. So this is the first row where it spotted a null value in the age column and it basically removed that. After that, it also spotted the null value in this specific row where the null value was also present in the salary column, but it doesn't matter. This row basically got deleted because it holds a null value in the age column. So this is how it removed the null values. Fine. So this was dropping the null values from a specific column. Now moving ahead to method 3. Let me just write it here. So method 3 is substituting the values for null data. So till here we saw the methods of dropping the rows where we have null values. Now we will substitute some values for them. Now for substitution, we cannot substitute the values in the columns of different data types. Like if we want to substitute in a column that holds a string data type, we can only do that. And if we want to substitute a value in the columns holding the data type integer, we can only do that. So we have to do this separately. So starting with, we will do it for string. So here I will just say 3.1 for string. So first we will substitute some value for the string columns. So let me create one more copy of data frame here, which is I guess 5. Now here I will say df5, here I will say df5 dot fill na. Again, you can go ahead with the different method as well. You can also use na.fill and also fill na. Now here you have to give the word with which you have to fill the null value with. So as you know, you just have a single string column in this data set, which is degree, and it holds just a single null value. So on the place of this null value, you can either fill it with the keyword missing or with the word unknown or with the word na. But we will prefer the word missing here. So let me just write it missing. Let's run that and let me just display the data set here. So as you can see, on the place of null, now we have this word missing. So we have successfully replaced the null values from the string columns with the word missing. You can replace it with any word that you want, but these are some basic standard words like unknown, missing and na. Secondly, we will do it for integer. So let me just write it here, 3.2 for integer. Now for integer as well, we have two different methods of substituting the values. Firstly, we will substitute the integer value, basically the missing integer value, with some constant value. So let me just write here, substituting with constant value. Let's say we are substituting the null value with the constant value 0. So here I will create one more copy of the data frame, and here I will say df6 dot, let's use the na.fill method now. You can use both these methods, either this one or this one interchangeably as per your convenience. So here I will give 0. Let's run that and let me display the data set for you. So as you can see, on the places of null in the columns of integer data type, we have 0 now because we have replaced the null values from the integer columns with a constant value 0. This is the standard value whenever you want to replace any null values from any of the columns that have integer data type. Most of the times your constant value is 0. Now again we will do it for integer, but rather than substituting for the constant value, now we will fill it with the statistics of that column. So let me just write it here, 3.3, and here I will say for integer, here we will perform imputation, that is filling the null value with statistic of that column. Just a minute. Fine. So rather than filling the null values with the constant value, here we will use a different method where we will fill the data or fill the null values with the statistic of that column, that is either the mean of that column or the median of that column or something like that. So let me create one more copy here of dataset and let's run that. Now here we cannot directly perform imputation. We first have to extract the numeric columns here. So here I will say numeric columns and I will say column name for column name and data type. in df7 dot dtypes. So if int in data type, let's run that. So this is where we have extracted the numeric columns from the data frame. Now after extracting this numeric columns, we have to perform the imputation. Now you might know that in scikit-learn we have the simple imputer module with the help of which we perform imputation. Similarly, here in PySpark we have an imputer module that we have to load from PySpark, with the help of which we can perform imputation. So starting with, let me first display the numeric columns list to you. So as you can see, it have extracted all the columns with integer data type, or we can say with the number data type from the data frame. After doing this, let's start performing imputation. So now here we have to say from PySpark.ml.feature, we have to import imputer. After importing the imputer, then we have to create an instance of that. So let's name it as imputer and just a minute. And here we will load the module. After loading the module, here we have to give three attributes: input columns, output columns, and the strategy with which we are going to perform the imputation. So let's say here input calls. So rather than giving all the numeric input columns explicitly here in a list format, what we can do is we can directly pass this numeric columns here. If you don't create this list of numeric columns, you can still go ahead for performing imputation. Just you have to give all the columns there manually, like age, then experience, and all those. But if you don't want to give all these columns explicitly when you have a large data frame, in that case you can go ahead with this method of numeric columns. Now after doing this, we also have to give output columns. So here we have to create the names for our new columns that will store the transformed value. Let's name this column as call name, plus here we will add a word of underscore imp, with the help of which we can identify that this column is an imputed column for call name in numeric columns. So basically what will happen is it will extract the column names from this numeric columns list, and after extracting this column names, then it will add a word further that of underscore imp, with the help of which we can identify that these columns are the imputed columns, and then it will give that names to the new columns. So after doing this, then we have to specify the strategy here. Now the strategy is with the help of which you are going to fill the null values. So here we are going to fill the null values, or we are going to impute the null values with the mean of that particular column, and hence the strategy is mean. So after that, here we will say df7 is equal to, now calling that instance of imputer, making the use of fit method. First we have to fit this method, and we will fit it again on df7. After fitting it, then we can transform it. So transform, and again we have to give the same data frame, which is df7. Now while using sklearn library, there we directly have a fit underscore transform method, but here we don't have such method. Here we have to use fit and transform both these methods individually. So first we have fitted the module, and then we are transforming the values. Let's run that. Now let me show the data frame to you. So as you can see, three new columns have been added in the existing data frame: age underscore imp, which is an imputed column for age; experience underscore imp, which is an imputed column for experience; and same goes for salary. So here you won't find null values anywhere. If you see here, on the place of null, where we initially had null in age column, now we have the value 27 there. Similarly, the other row where we again had null value in the same age column, even there we have this value 27. Which means the mean of age column is 27. Similarly, if you see for experience column, here we had the null value in the last row, and in the imputed column you can see on the place of null, now we have the value 3, which means the mean of experience column is 3. And you can even confirm that using this method. Let me just say here df7 dot describe dot show, and let's run that. So here you can see the mean for degree is null because it's a string column, and we cannot have the mean for string column. Then the mean for age column is 27, which is in float format, but here we are using the integer columns, and hence it has only considered the integer values. Similarly, the mean for experience column is 3, as you can see. So these are the same means which we have substituted here in the data frame. So this was the method of imputation, where we are filling the null values with the statistic of that column. Now that we have created the imputed columns, which doesn't consist of any null values, so we can delete this previous columns that consist of null values originally, like age, experience and salary, and we can only keep this imputed columns. So to delete the existing columns, what you can do here is, here you have to say df7 is equal to df7 dot drop, and instead of manually giving the column names that you want to drop, you can directly pass the num calls here, which is the list of existing columns that we had in this data frame. Now as we are passing a list here, you have to give an asterisk here. Let's run that, and now let me show the data frame to you. As you can see, now this data frame only consists of imputed values for the integer columns, not for a string. I'm not talking about string here, I'm just talking about integer columns. So these are the various methods of checking for null values and handling them in PySpark, which you might find a bit complex here as compared to scikit-learn, but with practice it will feel more easier. So that's it for the video. Thanks for watching.